On behalf of VMUG, I'd like to welcome you to today's webcast, Everything You Need to Know About Benchmarking Application Workloads, moderated by Mike Grandinetti, Chief Marketing and Corporate Strategy Officer of Reduxio. Thank you for participating in today's webcast and for your continued support in the global VMUG program. You can learn more about VMUG by clicking the Documents in your resource list widget to the left. Before we begin, I have 3 quick housekeeping items. First, today's webcast will be recorded and available for on-demand. Second, a Q&A session will follow today's presentation. All questions will need to be entered into the Q&A widget window to your left. And third, there will be a short online evaluation that will pop up as you exit the webcast. Please make sure to take a minute and let us know what you thought of today's session and what you might like to see going forward. All right, so let's get started. I would like to introduce you to Mike Grandinetti, Chief Marketing and Corporate Strategy Officer of Reduxio. I would now like to turn things over to you, Mike.
Candace, thank you so much, and welcome everybody. Thank you so much for taking time out to join us today. We're looking forward to sharing with you some content that we hope will be valuable to you in your day-to-day professional careers. We're looking today to talk specifically about benchmarking application workloads, and is our custom, we've brought in 3 subject matter experts to help us explore this topic in detail. So we're going to get into 3 separate discussions. First subject matter expert will be Tony Palmer from the ESG Lab group, and I'll give him a more proper introduction in a second. Second presentation will be from Eyal Traitel, who is the Director of Technical Marketing at Reduxio. And finally, I will be conducting a fireside chat with a VMware user, Troy Richards, who is in the IT group at the Georgia Building Authority. So that's going to be our agenda for the day. Just a word or two about Reduxio. Reduxio is a company with its headquarters in South San Francisco and our development operations in Tel Aviv, Israel. When we launched the company a little over a year ago, we wound up winning Best of VMworld award. We've been shipping product now for just over a year. We have a very rapid adoption of customers across the world. In Israel, companies like Technion, the venerable Israel Institute of Technology, Elbit, one of their largest defense manufacturers, and the United States, companies like Kubota, one of the world's largest heavy equipment companies, the California Public Utilities Commission. So we've had an opportunity to begin to build the business. We announced just yesterday that we are in the midst of finalizing the raising of a $32 million Series C venture round, which will allow us for further expansion, and our founders come from companies like IBM, EMC, NetApp, Dell, and Equalogic. Next slide, please. So I want to introduce both of today's speakers first so that we can very quickly work our way through the program. First speaker is Tony Palmer. Tony is a senior analyst with ESG Lab. ESG is very well known to everyone in the storage industry. They've been a very active commenter, analyst within the storage industry. They've expanded to cover a wide range of infrastructure technologies. Tony is someone who has personally been involved in over 700 different benchmarking lab analysis and reports, and so he brings very, very deep expertise to today's discussion. Eyal Traitel, who is Director of Technical Marketing at Reduxio, has been in the industry for over 25 years. He's a successful published author, and he has been named Employee of the Year at Reduxio. Next slide. Okay, so, and then for our fireside chat, we've got Troy Richards. Troy has been in the IT space within the state of Georgia, IT infrastructure, for over 15 years, starting in the Windows era, evolving through Unix and now Linux. He manages a very complex infrastructure for the Georgia Building Authority, and we'll get into some of the discussions around the infrastructure that he's managing and how he's using benchmarking to help him do his job more effectively as we get to that part of the discussion. Next slide. So I'm going to turn the floor over now to Tony from ESG, and he'll take about 15 minutes to walk you through his thoughts on benchmarking. Thanks, Tony.
Thank you, Mike, and good morning, everybody. My name is Tony Palmer, as Mike described, Senior Analyst with ESG Lab. ESG, for those of you that might not be familiar, is an IT analyst, research, strategic consulting company, been around for about 18 years. So in addition to our market research, demand-side research that we do with and for IT vendors, we also consult with and for IT professionals like yourselves, business professionals, channel partners, and we cover the full spectrum of IT technology. When we started, we were originally the enterprise storage group, and so when I started about 11 years ago, I was focused primarily on testing and benchmarking storage subsystems, but that's expanded out quite a bit, which has been fun for me and hopefully useful for you. So we've already talked a little bit about this, so I'll just move right into it. So in today's data center, right, really, you know, virtualization is ubiquitous, VMware is ubiquitous, and in order to use that and leverage the benefits of that consolidated infrastructure, you need a shared virtual storage pool, right? And the opportunities and the benefits that that provides for you are, you know, in addition to savings from consolidation, hopefully increased availability and serviceability from having fewer things to manage, being able to respond more quickly to the business, to respond to business needs, automating business and mission critical activities like DR and data migrations, right? And of course, then also centralizing management, getting more control over your environment. So the issue is that there are a number of challenges when you have a single shared virtual storage pool. You know, you have to guarantee performance for your mission and business critical applications, right? You need to be able to provide quality assurance, right, to ride through spikes from other applications. During resource intensive activities, backups, restores, data loads, you need to be able to maintain performance of your critical apps, right? You need to be able to plan for both capacity and performance using monitoring and tuning the system as needed. And of course, when you have all your eggs in that one basket, well, you know, you have to ensure availability, right? It has to be available, and not just the data, but your applications as well. If their applications can't get to your data, your customers are going to get frustrated with your applications. You're going to lose money, basically. So the last bullet here, because everything and everyone is virtualized now, whether you're in a standalone, you know, on-premise data center, a hybrid environment, or you're completely in the cloud, right? Your I/O is virtualized. Everything is being run through essentially a blender as it goes through the hypervisor, and any you know, resemblance to standalone application workloads is being blurred. So there isn't really anything much like a fully sequential workload that's going to hit a storage array nowadays, right? That's going to be somewhat randomized and broken up because you'll have multiple applications all coming from the same host through the hypervisor, coming through the same storage adapters. And we'll talk a little bit about that as we move on. So bandwidth is very important to performance, right? Because it can impact application performance if there's a bottleneck anywhere in the system. And you know, bottlenecks can be created with either bandwidth intensive chunks of data, contention of resources, and various other applications like backup to disk and video streaming are two examples, right, that can benefit from lots of aggregate bandwidth, but also can cause bottlenecks if they are, you know, if they're stepping on other applications. So where do bottlenecks occur? Potentially anywhere in the stack, anywhere along the data path, right? So within applications themselves, if the application is starved for resources inside its virtual machine or container, yeah, that's going to prevent it from accessing the data as quickly as it needs to, and it's going to impact your customer experience. Lack of resources or shortage of resources in the hypervisor, on the storage network, under provisioning, in the storage array itself, either resource contention on controllers or contention of access to shared media, disk drives in particular. And of course, if you're replicating to another site or to the cloud, or just doing any kind of communication over the WAN, that is a very small pipe, and that's potentially a bottleneck if in fact you have to wait for data to propagate and get a response before your application can move on and complete a transaction. So there's lots of opportunities here for benchmarking to help you point out, for benchmarking to be able to point out the potential issues and trouble with storage bottlenecks. So let's get to benchmarking and talk about it. When you benchmark, right, you're basically running a workload against a system, and you're measuring metrics. So what metrics really matter? You'll look at any storage vendor's website, and they'll list how many IOPS their array can do, IOs per second. Right, so yeah, that's a basic measure of how much work a storage array can do. How many IOs can it move in a second? But you really can't use that alone to predict performance of applications, right? You can use it to determine the speed and efficiency of the controller, as it says here, but you need to look at IOPS in combination with response time. Right, how fast the IOs are returned to the application. Because sitting there as an application, if I'm waiting, if I'm waiting a half a second to get my, I've got waiting a half a second to get data back from the storage array, the user's waiting even longer. And when transactions take more than a couple of seconds, users tend to get upset, click through, go somewhere else, do something else. They're not happy with you. Throughput is somewhat is actually tied back to bandwidth, right? So the more bandwidth a storage array has, the more data it can move, in a given period of time. So it's basically for doing things like video streaming and backup and restore and doing data analytics, right? You need to be able to move a lot of data, and you need to be able to do it quickly. And then finally, down at the bottom there, talking about transactions. So all of the metrics up top you can measure at the storage array, very easy to do, and look at and see how many IOPS it's serving and how fast they're going. But what you really want to know in your environment is, how are my applications doing, right? And so looking at, say, an OLTP type of an application, right? Processing, I don't know, credit card transactions, right? You're looking at that application level and seeing how long it takes for that particular transaction to complete. And that's made up of many, many, many different actions, right? Many IOs, the response time of all those IOs matter. Sometimes it's transfers of data, larger or smaller chunks of data. That all matters, right? It's all everything operating together efficiently is incredibly important to the people that are using your systems, whether those are internal or external customers, right? You want to keep them happy, and to keep them happy, you want to make sure that transactions are completed quickly and efficiently. So over the last 11 years, I have used a lot of different storage and system benchmarking tools. So this list is, I call it mostly free and open source. Some are open source, some are not, some are licensed, but they're mostly free. And they're differentiated by how real they are and by how easy or complex they are to use. So as we move over to the left, things are a little bit more real world, because a lot of these applications require you to deploy real servers, operating systems, applications, maybe simulating real users. They typically require a lot of equipment to run. So for example, LoadSim for email is actually a setup where you set up Exchange servers and actually run a simulated, a live load of simulated email users against those Exchange servers. On the other side, looking at, for example, JetStress, those two, by the way, are utilities provided by Microsoft for email sizing and benchmarking, right? So JetStress is a utility that simulates email activity against an actual database, that's the Jet database that's used by Exchange. However, that does not actually simulate real users. It just simulates the traffic against it, right? So it's easier to do that benchmarking yourself. And really that's across this spectrum. Each of these, except for the 3 iometer, VD bench, HCI bench, each of these here is designed for a specific type of traffic, right? Be it database or file shares or email. The difference between those and, say, iometer or VD bench, they are highly definable. So you can go in, create a bunch of virtual machines, and then have each of those virtual machines drive a specific workload that you very specifically defined. And that is interesting because you can, well, it's great because you can really define it any way you want and make it do anything you want. The bad news is you have to define everything that you want, and if you don't define it precisely, you could miss you could miss an important metric that's important to your application. We've used these tools extensively. They've done right by us in testing things like how do specific systems respond to multiple different workloads coming through a virtualized, through a hypervisor, through VMware. We've used Iometer, we've used VD Bench for that. HCI Bench is also interesting because that is specifically for hyper-converged type of environments, right? And we used that recently in a lab validation. And it allows you to really test, to scale very big and very wide and actually test a lot of different types of I/O. So having said that, there are also some commercial benchmarking tools that we've had experience with over the years. Here are 3 of them. So they all have some pros and cons associated with them. The pros are they can generate either real or very, very close to real application workloads, using different access I/O and data access patterns. In some cases, they require live application servers, so that makes them more complex and more difficult to set up and manage. In other cases, they can actually take packet captures off your network. They can take captures from your storage arrays, and they can generate and replay an actual storage workload that's been received by one of your existing storage arrays, and then replay it against another one that you happen to be evaluating. So, those are all the pluses. The cons are the cost, right? I mean, basically everything I showed you on the other screen, you'd be able to download and install and execute yourself for relatively little or no capital expense. These all cost you something, and in cases, anywhere from several $1,000s to tens of thousands of dollars, right? For the ones that are based on hardware appliances. So if, in fact, you're in a very large environment and you spend a lot of time evaluating hardware, this might make some sense to you. But if you're a smaller operation and you want to be efficient and you want to be able to specifically, compare a couple of different storage arrays, you may want to take a look at some of these benchmarking tools. So, which gets me to my last slide, and that's dealing with vendors when you're doing actual bake-offs and comparisons and evaluations, right? Vendors will always tell you, well, we'll give you as many IOPS as you need. We can, we will give you, they're, especially in the all-flash arena, they'll tell you we'll give you millions and millions of IOPS. And some of those claims are pretty extraordinary. And really, extraordinary claims always require extraordinary evidence, or at least clear and defined and provable evidence. So here are some questions you should ask your vendors and yourselves, right? So if you see a claim of millions of IOPS, okay, great. Is that an industry audited or a peer-reviewed benchmark result? If it is, great. Show me where that is, right? Consider for yourself the freely available, easy-to-run performance benchmark tools that you can use during your evaluation of the product. If you're comparing multiple arrays or multiple systems, try and compare configurations that are as alike as possible, right? Apples to apples. This is all pretty obvious stuff, but things that you just really do need to think about. And keep in mind that you're probably going to be more concerned with price performance, what do I get for a given dollar value, rather than where do I get the biggest number from. When you're looking at published numbers and published claims, right? Make sure that you understand what the hardware configuration and cost was. Vendors will often post a number for a particular array, and that happens to be for that array when it is stuffed full of all flash, right, and running a highly cacheable workload, right? What workload was run to give you those millions of IOPS? What was the working set size? And a working set is just basically how much data the benchmark is using to generate that workload. And if that working set size is smaller than cache, you really, you're not going to, you're basically not going to hit the back-end storage. You're not going to get a real view for how that system's going to operate in the real world, right? Latency is always important, and also, if you have the ability to extract this information from your existing storage arrays, look at how many IOPS you're currently consuming and how many you really need, right? Really, that's right sizing your environment and planning for a little bit of growth is really important and can save you a lot of time and effort and money. In the last few items, thinking about other features that can have an impact on performance, right? Data protection features, snapshots, replication, backup restore. Data reduction and compression can have a big impact depending on the architecture of the system, on how much data that system can store and how well it can perform for your applications. And then finally, how does it perform through failures, right? What's the availability like when a disk fails or a controller goes offline or you have to upgrade a component? So all great stuff. We're going to be open for questions at the end of this, but my part is completed. I just wanted to say thank you very, very much for your time. My contact information is here at esg-global.com. You can click on Tech Validation and see you can see any lab validation we've done. They're all available for free download for the public. So once again, thanks very much, and I'll pass it now to Eyal.
Yeah, Tony, thank you. That was great. Eyal, looking forward to what you will now sort of add, the new dimension you'll bring to this discussion.
So thank you, Tony, and thanks, Mike. So Tony, thanks for your great overview. I'd like to actually take the discussion a little bit deeper. But first, if you think about storage benchmarks, I had to write this one disclaimer first: is don't believe anything storage vendors tell you about performance, and that's kind of a continuation of your last part. Unfortunately, customers, as I see it, are flooded by different claims and half-truths by either vendors or their employees, and it's a little bit of a challenge for customers to figure out what's true and what's not in the industry. So my first advice would be just do your own research, do your own reading, validate the claims that you're actually receiving from vendors, and go from there. So why run benchmarks? What I see is that some may want to find performance limits of a certain setup. That might be finding the maximum performance of a certain environment, which may consist of compute, network, and storage. It may be just to find the maximum available performance of a given storage system setup. It may be to compare between different storage systems to identify. I want to buy the fastest system out of these three. I want to find which one is the fastest. It could also be to learn a certain behavior of a setup or a setup that I'm planning to actually install or configure, is to identify how does it behave under higher load maybe. Maybe I'm planning to expand the number of users that I'm pushing into the system. Today I have 100 users. I'm planning to grow into 200. How will that setup will perform? And I keep saying setup because it's not always just the storage. It's an entire setup that includes the storage system, and that's quite important in the way you set up your test environment. And third, and I think it's kind of the most important, and many people are forgetting that it's all about applications, and you want to actually simulate a certain application performance and not necessarily just a synthesized workload. I mean, we've got a lot of customers that are testing something and they say, oh, I get this performance or that performance, and you just see that this test is not really representing what they're actually trying to achieve for their users. So what's the ideal way of using benchmarks? First of all, there's something that I just saw across my career is that people just forget about doing, is to create a baseline. So I just installed my new shiny storage system, and it's set up in my network, and I'm all happy. That is the perfect time to actually perform a baseline test to see what is my performance right now, day one, when I configure that setup. Write it down somewhere, and this would be used as a reference in the future for any performance diagnostics that you may need to do in the future. So remember what was your exact performance in day one and different characteristics of the IOPS and throughput and the different application behaviors and so on, because later on you may run into a performance problem, which may not be a problem at all. I mean, it was a problem even in day one. You misconfigured your setup. It was bad even in the first place. So it's good to start with a baseline performance test. And again, as I said, you want to test a realistic application, and I'm going to dive deeper into this in a moment. And obviously, start working. That's why you purchased those systems. But then keep running those tests once every few months to just validate whether you're keeping into how do you fare against your baseline. And obviously, this is not always possible in a production environment. But even with noise, traffic, while you're running a benchmark, this is a measurement that is worth your effort. So how do you configure? How do you confirm the best performance? So I just thought that could be an interesting way. I found myself comparing against others. This is me in the gray shirt in my first ever Aikido lesson, with 4 black belt Aikido gurus. Actually, second on the right, from the right, is Mark Wiener, our CEO. He took me to one of his lessons, and I found so much enjoyment in Aikido that I keep practicing it till today. And actually, one of the interesting things to say about that is one of the key elements of an Aikido lesson is that you have to clean the mess at the end of the lesson, and everybody participates in that practice. And this is kind of a motto that Mark likes to talk about internally in Reduxio, which is part of our culture, is clean the mess, which means everybody participates in everything, and we do our best for our clients' success. So just for those who are curious, I fared pretty much okay, and I still survived that one lesson enough to keep practicing Aikido, and I recommend it to everybody else. It's great fun. So I don't want to scan the entire set of benchmark utilities. I mean, Tony gave a great overview there. We are actually planning to post a great blog post on our blog, beyondtheblocks.reduxio.com, that provides a very detailed review of storage utilities. And we actually found a great interest in the registration to this session and in general in this topic of storage benchmarks, so much that we decided to expand this one blog into a series of additional blogs where we will post more step-by-step instructions on how to run IO meter, how to run FIO, and so on. And some of it, as we've seen, is kind of missing on the internet. There's some information on how to run benchmarks, but it's not always as detailed as we would like it to be. So you should go search for that and go look for that in the near future. So how do you run benchmarks? First of all, some definitions. Let's talk about different kinds of I/O patterns. Small I/O. So typically when we talk about small I/O, we like to talk about 4 or 8 or 16K. In many cases, this is 4 or 8K. You want to represent the application block size. You want to simulate the higher level application I/O size. And some databases use 4K, some databases use 8K, some file systems use different sizes. You have to find out what is representing your small I/O. And there's been actually quite a lot of disagreement in the vendor community about which I/O size to use when you run benchmarks, but it's actually not a question that the vendors should disagree about between themselves. It's more of what does represent the best your own workload in your organization, in your environment. Large I/O is typically 32K or above. In most cases these days it's 64K or higher, up to 256K, which is some of the OS's maximum I/O size. This typically represents a large I/O. Sequential I/O is when I read data from beginning to end, more like a backup stream where I read everything, I write everything into a certain system or reading it back. Random I/O is when I actually read data or write data all around the data set in random offsets. And this is very important to ask customers for the working set size, across which size of a data set you're actually performing the I/O. And this is very important because some of it is cached and some of it is not cached. And you really want to identify that up front when you're planning your testing. I'm going to talk about four-corner testing in a second as a way to identify system limits. And obviously, one of the goals of running the benchmark is to identify the bottlenecks that Tony was talking about earlier. Simulating applications, the key before the test is to identify what is your workload. So let me expand a little bit about it. So four-corner testing it's very recommended to start with a test that will frame your maximum performance in different characteristics. So before I start simulating any application load, I want to find out what is the maximum possible performance I can get out of a certain setup that I have. And this is typically a little bit more difficult to run after a system is in production. So it's very recommended to start running that test, before I actually make it, change a system into a production mode. If I do, so what are the four corners? Large sequential write. This will identify what is the maximum theoretical performance, or not theoretical, practical throughput that I could write into my system. The same goes for large sequential read. I'm identifying specifically here that read may be entirely cached from the system's RAM. This would be the real theoretical throughput of the system, which is important to understand. Maybe I have a networking problem, for example, that limits my capability to reach the full potential that the vendor promised me to receive from the system, and it's not a problem with the storage system, it's a problem of my network setup. So I got to fix that before I go live. And obviously, read from media. Most workloads do have to read some data from media. They are not entirely cached. So it's very important to test the system under a real workload profile, which does have to read, unfortunately, from media. That's why I bought a storage system. Small random write, very obvious, relates to almost any workload that you can imagine today is random and has to write data. And random read, the same discussion on caching. Make sure that it's test cached, but also test non-cached workload as well to be more realistic. And there could be many setup limits. You need to ask yourself these questions and make sure that your testing is answering those questions. Where's my bottleneck? Is it where I expect it to be? Do I have enough network bandwidth? Do I have enough server power to actually saturate my storage system in the testing and so on? And I may not have enough components and so on, but at least I figured out that this would be a limitation of my testing. And that's important to know up front. So I would like to actually simulate real-life workloads that are running in the organization that my system will have to actually withstand in production. So backup is typically a large sequential write. I will pick large I/O sizes. I will pick 100% sequential write in my storage benchmark utility configuration. Restore, the entire opposite. It's a large sequential read. Obviously, it's an uncached read. If my system has 16 gigabytes of cache, probably I'm backing up terabytes of data. I'm not backing up just the 16 gigabytes. So I actually have to read a lot of data during the benchmark to represent a real restore scenario. Databases, typically, the general rule of thumb is OLTP type of workload of a 70% read, 30% write, or 80-20 configuration, 8K, depending on the database type. I mean, Oracle has default 8K, SQL Server has various different workloads, and depending on how you want to simulate them and how sophisticated you want to go, and depending on the tool. I mean, some of the commercial tools that Tony mentioned are capable of performing a real database workload, so you don't need to think about these at all. But if you're using a simpler open source tool, you have to configure the tool to simulate these workloads, and you can go as simple as just keeping 70-30 8K 100% random workload, or configure various profiles to run in parallel. It could get complex. And obviously, virtualization makes it very complex to simulate real application performance because your applications are running in parallel on the same environment, and they mix between themselves. So how to find your I/O sizes? There's different ways, different tools. I don't want to go too deep on that, and it's not so simple. You can read the applications documentation. You can investigate it yourself using low-level tools like TCP dumps and so on, or consult with others, the internet, vendors, and so on. Benchmarking pitfalls. There could be many of these. You're running mixed workloads, one together with the other, different cache sizes, the I/O depth of the test, how many I/Os are running in parallel, many or small amounts, and so on. Are you testing a raw device or a file system? You need to be aware of what you're trying to simulate and what is the performance benchmark utility. How is it configured? Is it matching your end setup? And parallelism is another potential problem. Are you running a single file copy test? It may not represent your real workload. Are you performing data reduction functionality? Is it impacting your performance? Is it not impacting your performance? Is it optional or not? And so on. So just to comment on why Reduxio is talking about benchmarks. So earlier on at Reduxio, we decided that what we'd like to do is to focus on real-life scenarios, real-life application workloads. And that's how we came to start testing with storage benchmark utilities. I think all along since we started, that was our key goal, to try to simulate real-life application workloads and focus our performance tuning on these real workloads. So Just before I end, just a few words on Reduxio and our technology. 3 key elements: recover to any second. One of the key features of key capabilities of our technology is called backdating, is the ability to take applications or virtual machine data stores back to any second. So for example, if my environment was attacked, for example, by ransomware, or I have any kind of logical problem with my data, I could actually restore take back an entire data store full of VMs, or just a single VM back to an hour ago in 2 minutes and 3 seconds, and I don't have to do any planning upfront to capture any backup before or snapshot or anything like that. So I can just take data back to any second, and it's very simple and intuitive. Of course, we focused a lot on performance. As you will see in the next slide, some example performance results from our customers. We tune our use of Flash. Obviously, Flash is now ubiquitous. We're becoming one. And the way we internalize the use of that fast media in our product is very optimized, because we use Flash as a full tier for capacity, and we store on that tier just compressed and deduped, very small and compact part of your data, but also the hottest part of your data, and we keep the rest on higher capacity, more cost-efficient media. And we'd love to talk with customers and show them how it works in reality with real application workloads. And obviously, we focused also a lot on the elimination of complexity. A lot of vendors talk about it, but we believe we cracked this complex problem of making storage simple. How do you assign volumes and hosts in one go? How do you make it simple? So just a word on our performance results with VMware users. Dingley Press, 5th largest catalog printer in the US, in the East Coast, is seeing great VM performance versus what they've used before. Obviously, backdating allows them to recover VMs way faster than their previous methodologies. Catbird is an advanced network security virtualization innovator in the West Coast, in the Bay Area, that is seeing great database performance with us, and they have thousands of VMs, and they see very low latency with our product. And Barnstable Police has been a very key customer for us in the largest city in Cape Cod, where they, on one hand, see great VDI performance results, much faster boot times and so on, but they've saved a ton of time on recovering from ransomware attacks, and they were very public about those recovery attempts and successes. So thank you very much.
Eyal, that was great. Thank you so much. Oh,
Thank you.
Some repetition on the line here. Is that hopefully that's done? Great. All right. So now for the final part of our discussion, we're going to talk to a VMware user, someone managing a complex environment. Before I do bring Troy into the discussion, I just want to highlight one thing. So Eyal just mentioned the Barnstable Police Department and ransomware. A few months ago, Reduxio partnered with VMUG, and we did a webinar dedicated to ransomware. It was well received enough that VMUG wanted to rebroadcast it. So for those of you who are thinking about ransomware and how to potentially deal with it effectively, just would point you to the VMUG site where you can watch the archive version of our ransomware webinar. So Troy, thank you so much for taking time out of your schedule to join us today. Appreciate the opportunity to have a discussion with you regarding how you're thinking about benchmarking. And I'd like to start by just perhaps if you could just describe to everyone what your role is today with the Georgia Building Authority and what the environment is that you're managing.
I'm actually the Assistant Director of IT Business Operations. Our environment runs a gamut. We actually manage 26 buildings, have a wide array of systems from very high impact, high use database systems to on-site, on-prem exchange, file and print services. as well as virtual desktops. We are running currently 120 plus virtual desktops. But we're 100% virtualized shop.
Please continue. Okay.
And just we've been in the virtualization technology and in VDI now for 6+ years, and virtual services or virtual servers using VMware for 10 to 15 years. So we're very experienced with the virtualization and the storage side.
That's great, Troy. I guess, as we were getting ready for our discussion today, you had mentioned that you've spent 15 years, within the state of Georgia's, IT environment. Can you maybe spend just another minute talking about some of the other changes that you've seen over your 15-year career as the data center has evolved and how it's impacted you and what you do every day?
Yes. Well, when I started, we had an entire floor of the building devoted to data centers, racks and racks of equipment, lots of power, lots of cooling, and you basically had 2 U of space devoted to an application, whether it was like heavy hitter or whether it was just sitting there being a Windows SUS server. Over the years, we've consolidated down. VMware became popular, or at least, it's been around for a long time, but it became like, bleeding edge, at least to us around 2006. We adopted that, and it took very well with us. But then our problem went to the storage side of the house. You need faster storage, you need faster SANs when you're consolidating all these servers down. And now we are skip forward from that. That was virtualization of servers. We started virtualizing desktops about 6 years ago, from CAD to financials to, like I said, we run the gambit of apps and users. And I think we've got a very successful VDI production and server production environment today.
Okay. And I think you shared with me earlier, Troy, that you had gone through some consolidation as well within your storage environment. Can you share that with everyone on the phone or on the webinar?
Yes, actually, just recently, one thing I would like to point out is once you lock yourself into a storage platform, it's very hard to move because all the pricing is built on expansion of that system. So we used a system for a while. And basically, we kept building upon it. And I think we reached the edge of its capabilities. But we went from straight up 15,000 RPM drive array cages to 10,000 RPM SATA for less highly used data, and also hybrid cages we tested for, or actually through a production for our VDI environment. And we've actually consolidated, as of today, we've consolidated 9 SAN cages with 24 drives in them apiece, from the hybrid, from the 15,000 RPM, from the 10,000 RPM SATA drives. We have consolidated all of our storage into one Reduxio SAN. And it's handling it like a champ.
And so what does that mean for you and your team and your ability to deliver the services that you're committed to for your business users?
Well, one, we're saving utility costs on electricity. We're saving maintenance costs on 8 SAN cages. And one big difference, I mean, I don't know how deep you want to get into Reduxio at this point, but that one SAN cage is running circles around what 8 of our individual SAN cages used to do. We've been in production.
Yeah, I'm sorry. Yeah, we'll take some of that in the Q&A. I do want to, and I appreciate your willingness to do that, but I'd love to get into the topic of benchmarking if we can. And just, we've heard from 2 expert speakers just before you that have shared their perspective. How would you characterize the way you think about benchmarking workloads to our audience today? What are some of the things that, from your perspective as someone who's been managing complex data center environments for 15 plus years, what are the key things they need to think about?
One thing I would definitely, I wrote this down when Eyal was talking. Don't believe anything the vendors tell you. It's like that is like gold. Everyone will come in trying to sell you, and they will tell you astronomical IOPS, and this will be the solution for you. Test. Whether it be with the benchmarking tools that were discussed by Tony, or even as simple as just restoring some backups and running your own benchmarks, whatever it may be, in-house against the systems. But definitely do not believe what the vendors tell you. Run your own tests, run multiple comparisons, and because in the end, the choice you pull the trigger on is what you're going to be with for 3 to 5 years.
Okay, so clearly, trust but verify for sure. And then now, once you get into the practicalities of that, can you talk a little about your prioritization of benchmarking? I mean, we heard from Tony that he's recommending that benchmarking is done on a rather continuous basis, right? So how do you employ this in your IT environment, month after month? Is it mostly just to evaluate new vendors coming in, or are you using benchmarking more as an operational tool as well?
A little bit of both. We did use it to evaluate new vendors coming in, but we do actually keep monthly metrics on our IOPS and any kind of latency we may have with our storage. I mean, other than that, we are that's pretty much it. We do keep continuous benchmarks on hand, as Eyal suggested, but we aren't. We're not a giant enterprise shop, so we aren't on the level of what they were describing. And I'm sorry if I'm appearing kind of scatterbrained at the moment.
No. Troy, it's great. I mean, just looking to just get your perspective, I realize that every environment is different, and I guess maybe let me wrap up by asking you one last question, and then we'll open up to Q&A from the general audience for all of our speakers today. So as you think about where we go from here, right? We're seeing a lot of focus on hybrid IT and just a tremendous amount of rapid change coming at us faster than ever within the data center. What do you expect to be some of the big challenges just ahead for you, and how will benchmarking help you deal with those?
Sorry, tons of notes.
Is there any one specific challenge maybe that you guys are investigating, as we sit here with you and your team and thinking about the incorporation of some new storage technologies or some new capabilities that are going to require a lot of thought and a lot of benchmarking before you're comfortable with deploying?
I would definitely suggest with VDI, if anyone is attempting, or if they haven't already dabbled their toes into VDI, that is one of the major things. If you fail somewhere in your benchmarking on servers, then perhaps you can limp along and survive, but you cannot. You need to do your homework on your storage for virtual desktops, especially the progression of Windows from Windows 7 to Windows 10. They are IOP hungry beasts, and that's pretty much all I can say. That's been my role for the last major push for the last 3 years is getting VDI with real desktop experience to the end user, and a majority of that is dependent upon what kind of IOP throughput you can actually get to the guest.
That sounds great. So, Troy, thank you so much, and I'd love to now open the floor up to questions from our listeners today. Thank you, Troy. So here's a question from the audience, Troy. It's directed specifically at you, and it's how much storage in terabytes does the Georgia Building Authority use, and what's the total number of virtual machines? And that's the first part of the question.
Okay. Well, first of all, we are when I say we consolidated the 8 SANs, they were before the time of dedupe. So we had around 80 to 90 terabytes of actual data. That being said, on the new SAN cage with dedupe in it, we are currently at 15 terabytes of user space. The number of VMs, we are between 50 and 60 current production server VMs, which can run the gamut from SQL servers, application servers, file and print, specific application servers. And we are currently at 120 virtual desktops, Windows 10 virtual desktops, and they run the gamut from just normal workstations with Microsoft Office to full-blown production AutoCAD workstations, heavy use graphics desktops, such as that.
Great. And here's the second part of the question, Troy. How much of that is the block history that's required to recover at any point in time using the Reduxio backdating capability?
We have found that with the servers, which is what we mainly care about, it really does not, the history does not consume a lot of space. And we've been very happy with it. The nature of the way that desktops do I/O, we've had to kind of alter our history retention on those. But that I would say it's very minimal on production servers.
All right, thank you. As I wait for the next question to come in, I'm going to turn back to Tony. And Tony, having now heard Troy's discussion, any further thoughts you'd like to share with our audience today in terms of how he's thought about benchmarking within his IT environment?
Yeah, I would say that his experience matches what we've seen, in doing our validations of vendor solutions over the years, and couldn't agree more with his assessment of VDI. It is an incredibly resource intensive and puts incredible stress on a storage system. And you absolutely need to test that before you dive in.
Okay, Eyal, Traitel, any last thoughts on what we've heard from Troy today and how he's described his environment and how he thinks about benchmarking that might be either helpful to him or other folks listening today to our webinar?
Nothing in particular. I mean, it's obvious. I mean, maybe one comment on VDI. Yeah, we that's what we get to hear from other customers as well. It's kind of a hectic workload, and people need to do their heavy testing before actually going live.
Okay. All right. And then I think, Troy, I'm going to ask you one last question now. I'm going to pick up on the point you started earlier where you had said how deep you want to get into Reduxio and that your one cage is running circles around the prior 20 cages that were consolidated now. Maybe you can just take another minute to discuss what your experience has been in seeing that kind of capability and that kind of consolidation in your environment. And then we can wrap it up.
Okay. When the block history to that point, it actually depends on your actually history retention. I believe there are 4 different out of the box, 4 different retention policies that you can apply to a volume. What I have done on my servers, and so far I have not. I've used. I have 15 terabytes of user data, and my actual history with that is at 2 terabytes, and we've been on it now production for about 4 or 5 months. Question's gone away. The key feature that influenced my decision to deploy Reduxio is the IOPS. BDI is my driving thing, and it's the price point. I am a government institution. I have to, weigh the speed for the money to be a good steward of the taxpayers' money, and Reduxio came out on top in all of our tests.
That's great. All right. Well, listen, I know that we have hit the 1 hour mark, and just as a professional courtesy to our listeners, we're gonna wrap up today's webcast. So on behalf of Reduxio, this is Mike Grandinetti, Chief Marketing and Corporate Strategy Officer. I'd like to thank one last time Tony Palmer, Senior Analyst at ESG Labs, Traitel, Director of Tech Marketing at Reduxio, and Troy, who joins us as Associate IT Director for the Georgia Building Authority. Thank you all so much for sharing your time and, most importantly, your insights and expertise with us today. We appreciate it, and for our listeners out there, this will be archived. And again, there's also a Reduxio webcast that was done with the VMware Group not too long ago on ransomware, if that's something of interest to you. I'm going to turn this back over now to Candace from VMware.